So hello everyone, we are actually discussing some practice questions on this soil water relationships. In this video also I'll discuss one more practice question. So let us quickly look into this video. So what has been asked in the problem? A partially saturated sample from a borrow pit has a natural moisture content of 15%. So he has mentioned the soil is partially saturated and it is having a water content of or moisture content of 15%. That means first given data, water content is equal to 0.15. 15% means 15 by 100, that is 0.15, and bulk unit weight of 1.9 gram per cc. Bulk unit weight. Gamma B also he has given 1.9 gram per cc, and also he has given the specific gravity of solids is 2.70. G value also he has given 2.70. Now what has been asked in the problem? Calculate degree of saturation, void ratio, what will be the unit weight of the sample on saturation, this we'll discuss later. First we will solve A and B first. So degree of saturation. So what is the degree of saturation? We know the relationship between E into S is equal to GS into W. Sehwag. Okay, Sehwag we know. So E into S is equal to GS into W. Water content we know. Specific gravity we know. E we don't know. And if you know the E, then S can be calculated. S can be calculated. Now how to find out this E? So we know that E is equal to G gamma W by gamma D minus 1. E is equal to G gamma W by gamma D minus 1. So E is equal to G value is how much? 2.70 into gamma W in gram per cc, how much we can take? 1 gram per cc, divided by gamma D. He has given bulk unit weight. So we know the relationship between bulk unit weight and water content. Bulk unit weight, water content, and dry unit weight also. So that is gamma D is equal to gamma B by 1 plus W. What is that relationship? Gamma D is equal to gamma B by 1 plus W. So I am directly calculating how much it is, or I will calculate here. So gamma D is equal to gamma B how much? 1.9 divided by 1 plus water content will be how much? 0.15 he has given. So 1.9 divided by 1.15, that is nothing but 1.652 gram per cc. 1.652 gram per cc. So 2.70 divided by 1.652 minus 1. So E is coming around. E is equal to 0.634. So E is found out. Now if you know the E, then S can be calculated. So this S is A. So S is equal to G. G value how much? G value 2.70 into water content he has given is 15%, and E value we have found out is 0.634. So we know that E into S is equal to specific gravity into water content. So I am keeping degree of saturation in the left hand side direction, and remaining all I am sending it to the right hand side direction. So if you calculate from this formula how much the degree of saturation is coming around, 2.70 into 0.15 divided by 0.634. So S is coming around 0.6388 or 63.88%. 63.88%. So this is actually the degree of saturation of the soil. So void ratio we have calculated, and degree of saturation also we have calculated. And one more thing has been asked in the question. That means, what will be the unit weight of the sample on saturation? Here remember this thing carefully. On saturation means 100% saturation, that is when S is equal to 1. When S is equal to 1, what will be the value of gamma, means unit weight? So what we have to calculate? Gamma sat is equal to GS plus SE into gamma W by 1 plus E. So here S is equal to 1. When S is equal to 1, what will be the value of this gamma? So that only we are calculating. Gamma sat is equal to, so GS value how much? 2.70 plus S value how much? 1, and E value what we have calculated? 0.634 divided by 1 plus 0.634. So saturated unit weight is equal to 2.70 plus 0.634 divided by 1.634. This is coming around 2.04 gram per cc. 2.04 gram per cc. So the unit weight of the soil on saturation is equal to 2.04 gram per cc. 2.04 gram per cc. So this is the data what has been asked in the problem. So we have written down the given data, and we have taken some formulas from our soil water relationships, and we have solved this question. So thanks for watching my video. If you feel the content is useful, please like my channel and subscribe as well. Thank you.